Hello friends, this video on dual nature of radiation and matter part 13 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 12 before going ahead with part 13. Assume that the molecule is moving with the root mean square speed of molecules at this temperature. So now here we have to calculate the de Broglie wavelength of nitrogen molecule. Now for de Broglie wavelength we need mass and velocity. So in this case it says that velocity is nothing but root mean square speed because the molecule is moving with root mean square velocity. Right? So what would be the kinetic energy of the molecule? It would be nothing but half mv RMS square. Right? Also we know that at a temperature T, the kinetic energy is related to temperature by this relation 3/2 kT, where K is Boltzmann constant. We have studied all these things in our previous lessons, right? In class 11th, we have studied all these relations. So kinetic energy is on one side is equal to half mv square. On the other hand, it is also equal to 3/2 kT, where T is the temperature. Right? Now, let us calculate the mass of nitrogen molecule, because in order to calculate de Broglie wavelength, we need mass as well as VRMS. So for mass, we need to calculate the mass of nitrogen molecule. So this will be, this M is mass of N2 molecule. Now what is given in the problem? Atomic mass of nitrogen is given here. Now one molecule of nitrogen consists of 2 atoms. So the mass of one nitrogen molecule is equal to 2 into atomic mass, because one nitrogen molecule consists of 2 nitrogen atoms. So this will be 2 into 14.0076 atomic mass unit. So if you want to convert it into kgs, what is one atomic mass unit? It is nothing but mass of one proton, which is 1.67 into 10 to the power minus 27 kgs. So this is the mass of one nitrogen molecule, right? Now let us calculate. So we have calculated M. Now we have to calculate VRMS, right? Now from equation 1 and equation 2, from 1 and 2, we can say that half mv RMS square is equal to 3/2 kT. So 2 will get cancelled. From this we can say VRMS square is equal to 3 kT divided by M, or we can say VRMS is equal to root over 3 kT divided by M. So we know K, which is Boltzmann constant, that is 1.38 into 10 to the power minus 23. T is given as 300 Kelvin, and M we have already calculated here. So now we can calculate lambda is equal to H divided by M into VRMS. So this is equal to H divided by M into VRMS. We can write it as root over 3 kT divided by M. So this can be written as H divided by root over 3 kTm. So now if we put all the values here, we find that lambda comes out to be 0.028 nanometers. So this comes out to be the wavelength or the de Broglie wavelength of a nitrogen molecule. Let us look at problem 10. An X-ray tube produces a continuous spectrum of radiation with its short wavelength end at 0.45 angstrom. So that means the wavelength is given as 0.45 angstrom, which is nothing but 0.45 into 10 to the power minus 10 meters. What is the maximum energy of a photon in the radiation? So the wavelength of the radiation is given. So what would be the energy of the photon? Energy of a photon is given by h nu, which can be written as hc by lambda, because frequency is related to wavelength by this relation. Nu is equal to c by lambda. So this comes out to be 6.67 into 10 to the power minus 34 into 3 into 10 to the power 8 divided by 0.45 into 10 to the power minus 10. So this comes out to be 44.46 into 10 to the power minus 16 joules. If you want to convert it into electron volts, you just divide it by 1.6 into 10 to the power minus 19 joules, which comes out to be 27.6 kilo electron volts. So this would be the maximum energy of a photon in the radiation. Here comes problem number 11. In an accelerator experiment on high energy collisions of electrons with positrons, a certain event is interpreted as annihilation of an electron-positron pair of total energy 10.2 BeV into 2 gamma rays of equal energy. That means it is talking about a process of annihilation of an electron-positron pair. That means an electron is combining with a positron, and this results in 2 gamma rays of equal energy. What is the wavelength associated with each gamma ray? So we have to calculate the wavelength associated with each gamma ray. It is given that the energy of each gamma ray is the same. So if this is E, this is also E. Now, in this case, what is the funda that we will apply here? The total energy remains conserved in case of a collision, right? So, what is the total energy? Total energy should be conserved, right? So let us calculate the total energy before collision. Before collision, what is the total energy? Annihilation of electron-positron pair of total energy 10.2 BeV. So the total energy before collision is 10.2 BeV, which comes out to be, and 1 billion electron volt is 10 to the power 9 electron volts. That is 10.2 into 10 to the power 9 electron volts. This comes out to be 10.2 into 10 to the power 9 into 1.6 into 10 to the power minus 19 joules. So this is the total energy before collision. Now what happens after collision? Now after collision, total energy, let us call this energy as T1, let us call this total energy as T2. So what will be the total energy after collision? After collision, what happens? 2 gamma particles of equal energies are formed. So let us suppose each of them has energy E. So what is the total energy after collision? 2E, right? Now, according to conservation of energy, T1 should be equal to T2, that is total energy before collision should be equal to total energy after collision. So 10.2 into 10 to the power 9 into 1.6 into 10 to the power minus 19 should be equal to 2E. This implies E will be equal to 10.2 into 10 to the power 9 into 1.6 into 10 to the power minus 19 divided by 2. So this E comes out to be 8.16 into 10 to the power minus 10 joules. So this would be the energy of each gamma ray. What is E? E is the energy of each gamma ray. We have to calculate the wavelength associated with each gamma ray. So how do we calculate the wavelength? Let us do it here. If this E is the energy associated, so this energy is equal to h nu and this is equal to hc by lambda. So from this we can say that wavelength lambda is equal to hc divided by E. So h is 6.67 into 10 to the power minus 34 into 3 into 10 to the power 8, this whole divided by E, which is 8.16 into 10 to the power minus 10. So what is the wavelength? So we get that lambda is equal to 2.436 into 10 to the power minus 16 meters. Right? Okay. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.